Chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. Causality is entirely supported by you. If you'd like to support us and keep the show ad-free, you can by becoming a premium supporter. Premium supporters have access to early release, high-quality versions of episodes, as well as bonus material from all of our shows not available anywhere else. Just visit engineer.network/causality to learn how you can help this show to continue to be made. Thank you. Carnival Triumph. Cruising has long since transitioned from being the primary means of global travel between continents to being a tourist-driven industry. The ships have been built ever bigger with each passing decade, to the point at which the ship itself becomes its own destination. As of early 2025, the largest cruise ship corporation in the world was Carnival Corporation, who own and operate in part or in whole multiple sub-brands including Carnival Cruise Line, Princess Cruises, P&O Cruises, Costa Cruises, Ada Cruises, Holland America Line, Cunard Line, and Seabourn Cruise Line. They carried nearly 14 million passenger trips in the most recent 12-month period, which represents just over 40% of the global cruising passenger market. And within their slice of that, half of those passengers traveled with Carnival Cruise Lines. As of March 2025, Carnival operates a fleet consisting of 29 ships, and 5 more are planned to come into service by 2033. They were originally founded in 1972, and the cruise line went through many stages of designing and building ever larger classes of vessels, with the Destiny class bringing the Carnival Destiny to the fleet in 1996, and a few extensions to the base designs led to the Carnival Triumph launching in 1999 with the Carnival Victory in the year 2000. The Triumph has a gross tonnage of 101,509 GT, is 272 meters, that's 893 feet long, is 35.5 meters or 116 feet wide, also known as its beam, has a draft of 8.3 meters or 27 feet below the surface when fully laden, and consists of 13 decks in total. The Triumph was constructed at Fincantieri Yard on Monfalcone, Italy, and has a diesel-electric propulsion system that uses 6 primary generators to provide power to 2 electro-propulsion units. 4 engines are 16-cylinder Wärtsilä Sulzer, and 2 are 12-cylinder 12 ZAV40S medium-speed diesel engines. The ship has a maximum speed of 22.5 knots, that's 41.7 kilometers an hour or 25.9 miles per hour, with a service speed of about 20 knots, which is 37 kilometers an hour or 23 miles an hour. And it uses 6 transverse thrusters for maneuvering when it's in port. The vessel can carry 3,540 passengers across 1,379 cabins and has 1,118 crew berths, giving a maximum number of people on board possible of 4,919 people. Let's just call it about 5,000 people. A fair few. The Triumph was an older style of cruise ship, insofar as it had lifeboats, yes, but no tender boats. More recently, cruise ships employ multiple lifeboats that are self-propelled, and they do double duty. They are both a lifeboat in case of an emergency, but they can also be raised and lowered to ferry passengers to and from ports of call that don't have a deep enough berth for the cruise ship to dock at directly. At the time of its registration for service, the Triumph held all internationally required certificates for operation. Now, let's talk about the incident itself. On the 7th of February 2013, the Carnival Triumph, carrying 3,143 passengers and 1,086 crew, that's 4,229 people in total, departed Galveston, Texas, embarking on a 4-day cruise to Cozumel, Mexico, scheduled to return to Galveston on the 11th of February. At 4:30 p.m. local time on Saturday, the 9th of February 2013, the Triumph departed Cozumel on its return leg to Galveston. At 4 in the morning on the following day, Sunday, the 10th of February, diesel generators 1, 2, 3, and 6 were running with their loads balanced and continued to supply power to the propulsion system and all other ship services. As part of their normal operational checks, a crew member regularly inspects the engine rooms, with the inspection at 4:48 a.m. being executed without incident. At 5:16 a.m. and 5 seconds, diesel generator number 6 indicated a fire alarm on the bridge. Within 2 minutes, personnel had arrived to investigate and reported that oil was spraying at the number 6 engine and appeared to be spraying about 5 to 6 meters high, coming from beneath the deck plates and between the turbochargers on engine 6. and they recommended it be shut down immediately. At 5:19 a.m. and 28 seconds, the emergency stop button was pressed on generator number 6, and being a rapid stop, the engine was stopped within 2 seconds, with the fuel, feed, and booster pumps reverting to standby a minute later. As an extra precaution, the team in the engine room moved to the fuel oil separator room to isolate the fuel oil feeder modules for both engines 5 and 6, and this was completed by 5:25 a.m. and 45 seconds. Shortly afterwards, a member of the crew in the engine room party started subsequent inspections to confirm that there were no other issues and witnessed a fire ignite several meters directly in front of them in the aft engine room near generator 5, bank A, and that was at 5:27 a.m. and 13 seconds. At 5:27 and 47 seconds, the high fog fixed water firefighting system automatically activated. At 5:28 a.m., the first officer called an Alpha Team announcement. The captain woke and attended the bridge to assist. During this period, one of the engineers in the generator room noted that the fire suppression system wasn't fully operational and went to the fire system control panel, firstly to find that it appeared to be working on generator 6, but the lights were flickering, and shortly thereafter, they went out entirely. When the chief engineer, who had been awoken by the Alpha Team announcement, arrived at the generator control room, noted that the fire suppression system was completely offline, and then assisted in closing off all of the fuel system quick-shut valves. Noting that the air was becoming more difficult to breathe and the fire had not yet been put out, the chief engineer requested permission to use the CO2 suppression system. Since flooding the entire engine room with CO2 or carbon dioxide would also suffocate any people in that room prior to activation, a roll call is mandatory. When entering or exiting the engine room, personnel are required to tag in on a physical access board and to tag out again when departing. And based on this, there were only 2 personnel in the area who were very quickly accounted for. However, the design of the carbon dioxide system also meant an aft engine room activation would also impact the garbage handling area, and hence this area had to be checked as well to confirm that it was also free of people. Since the control board wasn't functional, it wasn't possible to deploy the CO2 system from the nearest location adjacent to the room, but rather from the carbon dioxide room directly, which was located on deck 11. For safety reasons, since the CO2 is more readily ventable in case of a leak at higher decks than it would be were it to be located down below. Upon reaching the CO2 room, it was found that CO2 was already present inside the room, and it was unsafe to enter without an SCBA, that's a self-contained breathing apparatus. So the electronics officer went to put on an SCBA before they could enter. At 5:36 a.m., the main switchboard tripped out and all power was lost, leading to the blackout tank releasing its fuel, meaning that whilst its fuel wasn't released to the fire, that left the blackout tank empty. Although it is important to note that this happened automatically by design at that point in the event of a loss of power from the main switchboard with the intention of preparing all engines for a rapid restart. At 5:38 a.m., the emergency generator had started and the electronics officer, now wearing an SCBA, finally entered the room and activated the system, quickly draining CO2 bottles 3, 4, and 5 for Zone A, and within that minute, the CO2 system had been successfully deployed. At about the same time, an announcement was made to all people on board via the public address system that there was a situation in the engine room, and at 5:46 a.m., the captain added to this that there was currently no requirement to report to muster stations. As the area had become quite hot, the personnel then used boundary cooling by using fire hose water on deck 0, though only applying it intermittently for fear that too much water could then create a flooding risk. At approximately 5:48 a.m., crew were finally able to re-enter the forward engine room wearing SCBAs. A temporary power feed was taken from the emergency switchboard in the propulsion room, and after nearly an hour from that point, the high fog system was once again powered up and able to monitor temperatures throughout the engine room. With loss of primary generator power, the emergency generator and onboard battery systems powered some devices to a limited extent. However, the ship was now effectively adrift. Without primary power, there was no lighting, no elevators, no refrigeration, and with limited power for recirculating water pumps, the toilets didn't flush and there was no air conditioning. At the time the ship began to drift, it was located some 296 kilometers, that's 184 miles or 160 nautical miles north of Progreso, Mexico, and 700 kilometers, that's 437 miles or 380 nautical miles south of Mobile, Alabama, in the United States. Given this location, tugboats were dispatched from Progresso and Theodore, Alabama, but by the time the first tug was within range on the following day, the Triumph had drifted 200 kilometers, that's 124 miles or 108 nautical miles further north, placing it now far closer to Alabama. During this time, passengers were requested to take some rather unorthodox measures, including defecating into red plastic biohazard bags and urinating in the shower recesses, since the vacuum liquid wastewater removal systems weren't functioning. During the night, it became apparent that without power, lighting, or air conditioning, those with rooms that had no openable door to the outside couldn't stay in their rooms, with rooms above the fire location also being smoke-affected. Many people began dragging their mattresses and bedding materials out onto the various decks in open air. Within a day, the decks of the ship resembled a shantytown of sorts, with some arguments breaking out from time to time over who was allowed to be in what space on the deck. Carnival had a large number of ships in the region, and they diverted the Elation, the Conquest, and the Legend to deliver critical food and supplies using their tender boats. However, it was considered far too dangerous with 6-foot-high seas and high winds to attempt to evacuate passengers off the Triumph via the tender boats from other vessels. Thankfully, all public toilets and a small number of cabin toilets had their vacuum water systems return to operation during Monday early in the afternoon. But that still wasn't very many. To ensure passengers didn't become upset whilst intoxicated, alcohol was no longer served during the time the ship was adrift, except from about 3:30 p.m. on Monday, the 11th of February, as a result of a directive that came from Carnival in Miami. However, it went about just as well as you might expect, and they reversed that decision about 5 hours later. Yeah, really, not smart, guys. At approximately 8:30 p.m. that day, the first tugboat arrived and began to tow the Triumph towards Mobile. In the morning of Tuesday, the 12th of February, when the ship was within range of the U.S. Coast Guard's helicopters, an emergency portable generator was successfully delivered, which was used to power some additional equipment as well as providing power for grills so they could prepare hot food. The Carnival Triumph would eventually arrive in Mobile, Alabama, in the early evening on Thursday, the 14th of February, returning to land 3 days later than planned. No one died, and no one was injured in this incident, but whether they'd be keen to take another cruise in a hurry, well, that's another story. Let's talk about the investigation. As the incident occurred within the jurisdiction of the Bahamas Maritime Authority, the BMA led the investigation in conjunction with the United States Coast Guard. The final report was released on the 12th of September the following year, that's 2014, and is just over 100 pages long. There have been plenty of allegations and claims made as to whether the Triumph should have left port in the first place. Whilst it's true that 2 of the 6 diesel generators were offline, and generator number 6 was overdue for maintenance, none of these things, being online or maintained specifically, would have prevented the fire or allowed the ship to continue to operate after the fire damage had been done. So what went wrong? Simply put, the cables from all 6 engines ran along a common cable tray section that passed through the area where the fire broke out. It's really that simple. The fuel line failed, however, there is no detailed analysis as to what specifically failed in that component, though it was heavily damaged by the fire, so it may not have been possible to determine if it was a manufacturing defect or if it had been improperly installed or damaged somehow in its use. So what can we learn from this? Fundamentally, redundancy is only as good as your weakest common single point of failure. The fire happened to occur in a part of the engine room where the power cables for all units ran through a common zone, and hence the fire took them all out at the same time. Yes, you had redundant engines and hence redundant generators, but without a genuine separation of all the constituent components that make up the entire system, you're prone to failure from a single event. The number one recommendation from the BMA investigation was for Carnival to review the electrical system layout of not only the Triumph, but of all others built at the same shipyard. Normally, in electrical engineering, we divide generators and switchboards into at least 2 buses, commonly just called bus segments A and B, with a bus tie that joins them together. When you need a highly available system to guard against a single point of failure like this, cables are run to the buses in different cable trays, trenches, or whatever, but that's referred to as geographic redundancy. Having such a setup means that if you size the cables and switchboards and circuit breakers correctly, you can then backfeed from A to B or vice versa and route around damaged cables and equipment while still maintaining supply. It's the sort of design decision that would have become apparent as part of a thorough hazard analysis, since normally one of the trigger words we will assess in a PHA or HAZOP is broadly fire. Beyond this, the automatic operation of the fuel oil system wasn't very helpful in this situation, and recommendation 4 from BMA calls out the need for a quick shut valve adjacent to the primary valve bank that would prevent this in such a situation in the future. Carnival took that and implemented it on all of their ships where this was an issue during 2015. The emergency generator didn't function very well either, with its power fluctuating wildly during use, which is what's referred to as poor governor control. In the investigation, they determined that genuine load testing of the emergency generator simply didn't happen prior to the incident. They tested it, but not on load. Since their recommendation to address this, Carnival added load testing as part of their emergency generator preventative maintenance procedures. Let's talk a bit about the aftermath. Following an extensive 4 months of repairs and retrofits to the tune of $115 million to avoid any stigma at all associated with its original name, Carnival Cruise Lines chose to rename the Triumph. It is now known as the Carnival Sunrise. Many of the retrofits involved improving redundancy, and one of these items was an additional emergency generator, located directly above the existing emergency generator to allow both port and starboard power routing connections. Additional cable tray protection has been added for many critical system cables, including primary power and the high fog fire system, to improve its resilience to high temperatures like those experienced during the fire. The garbage handling room had a fire door retrofitted to allow easier isolation from the higher risk engine room. For engines that used flexible fuel lines, like the one that failed on the Triumph, they had spray shields installed to protect hot engine components from fuel oil as an additional precaution. And of course, the primary power cable routes were changed for generators 1, 2, and 3, whereby cables from diesel generator number 1 now run along the port side of the forward engine room, then eventually along the port side of the aft engine room into the main switchboard from that direction instead. Cables from the diesel generator number 2 now run via the casing onto deck 1 and pass via trunking to deck A, and from there into the switchboard. And finally, cables from diesel generator number 3 are fed up to deck B aft and then via the garbage room into the switchboard. The cables from diesel generators 4, 5, and 6 were fully replaced, but they still maintained their original cable route. Well, that's certainly a step in the right direction. Personally, I would have split out the 4, 5, and 6 cable paths more, but then I guess I'm just cautious. So far as the passengers went, they were granted a full refund, reimbursement for transportation expenses back home since they went home to Mobile and not Galveston, as well as a one-time $500 US payment and a future complimentary cruise. Gotta say though, I'm not really sure how keen they'd be after this incident. Gotta say, anyway. Many passengers, however, were unsatisfied with Carnival's compensation offer and attempted lawsuits against Carnival relating to the incident with minimal success. In a statement issued by Carnival, they highlighted that the standard ticket contractual conditions at that time, and I quote, makes absolutely no guarantee for safe passage, a seaworthy vessel, adequate and wholesome food, and sanitary and safe living conditions, end quote. Well, I mean, that's just a bit much, isn't it? I mean, I can see why a cruise company would like to have that in a contract, but you shouldn't be able to enforce that in that way, surely. As a result of Carnival dodging the legal bullet, so to speak, in this instance, the Cruise Lines International Association, that's CLIA, drafted a Cruise Passenger Bill of Rights, or CPBR, and challenged cruise companies to sign up to it. There is a lot to the document, as you'd expect, but the following summary points highlight some of the key items for every cruise passenger's rights. They have the right to a safe journey, including functioning safety measures and medical care on board. They have the right to seek compensation for cruise-related injuries, illnesses, or wrongful deaths. They have the right to be informed of changes in itinerary, safety risks, or contract terms. And they have the right to fair treatment in the case of delays, cancellations, or onboard crimes. There's more, but I'll leave it there. Since the incident and signing up to the CPBR, Carnival have long since removed their no guarantee clauses I just referred to from their cruise ticket conditions. When you are designing for high availability, we need to fully appreciate what components work together, what components work separately, and confirm that cross connections exist between those components to ensure that there are no single points of failure And remember that that applies to their inputs, like fuel, and outputs, like electricity. Where you can't eliminate those SPFs, you have to ensure that they have the lowest possible likelihood of failure. For example, as an analogy, in the IT/OT computing space, these dimensions are sometimes referred to as failure domains. If we're designing a high availability node with server blades and network switches, we'll often have A and B power supplies, whose power supply rails are on opposite sides on the rear of the server tier, and each has powers fed to them from two different UPSs fed via different underfloor or overhead cable routes. In higher availability scenarios, server blades are kept in physically separate racks adjacent to one another, or even in a different room, or even in a different site or location. It just depends on how far you want to go and how much you're willing to spend. The generators, cabling, and power distribution on the ship is in so many ways no different to that, but they didn't consider geographical redundancy, and their design, therefore, was fundamentally flawed. The Netflix documentary focuses a lot on the people, the impact to them, and their personal situations on the ship, but glosses over the reasons behind some of the decisions made and hard work by Carnival and the crew of the Triumph. The fact is that the crew were the ones manually cleaning up a lot of the human waste, pulling together food for everyone using whatever they reasonably could without making people sick. I actually think that the actions of the crew are to be applauded. You have to remember that they were stuck there too, and they had to work through it all. Where the crew was working below decks had very poor ventilation. It was heavily reliant on artificial light, which was in scarce supply, and they couldn't just hang out on deck and wait for it to all blow over. But I digress. I've often pushed redundancy and availability and the need for spending that little bit extra to make it just that bit more reliable, and some people will push back on that. You don't need to be that reliable, for example, or comments to that effect. The problem is, though, if you were to calculate the ticket refund costs, the loss of foodstuffs, the generators brought to the ship, the tugboats, the next cruises that the Triumph was supposed to do, all of those refunds, the list of cost blowouts from this incident is many, many millions of dollars, and that's without even paying to fix the fire damage to make it seaworthy again. Suddenly, spending a few extra $100,000 on some longer cables and some more cable trays to have some geographical redundancy sure looks like one hell of a bargain. You don't need it until you need it, but when you need it, you really, really need it. And that is precisely why redundancy matters. If you're enjoying Causality and you'd like to support us and keep the show ad-free, you can by becoming a premium supporter. We have support options via Patreon, Apple Podcasts, and YouTube memberships as well. Just visit engineered.network/causality to learn how you can help this show to continue to be made. Thank you. A big thank you to all of our supporters. A special thank you to our silver producers, Mitch Bielger, Shane O'Neill, Jared Roman, Katarina Will, Chad During, Ian Gallagher, and Jamie Russell. And an extra special thank you to our gold producers, Stephen Bridle, Kellen Frodelius Fujimoto, Steve Branham, and our gold producer known only as R. Causality is heavily researched, and links to all of the materials used for the creation of this episode are contained in the show notes. You can find them in the text of the episode description of your podcast player or on the website. You can follow me on the Fediverse at chidgey@engineered.space or the network at engnet@engineered.space. This was Causality. I'm John Chidgey. Thank you so much for listening. For the record, I've cruised with Carnival 5 times since 2016, and we're planning an extended family cruise in 2026 with Carnival as well. I have to say, the cookies are pretty nice, and hang out on the Lido deck. That's where it's at.